All right, so I just wanted to run through a few limit laws real quick. Just a couple. Now, some of these get reused in lots of different ways, so just pay attention to some of the details and some of the nuances of how they fit together, and you can kind of reuse them from time to time. One of the biggest and more important ones that we deal with that seems overly simple is the idea of the limit of some number, let's just pick a number, say 5, as x goes to anything, say in this case 6, would just simply be that number, okay? Meaning that the generalized version of this is the limit as the limit of c, where c is some constant, as x goes to any number, we'll call that number a, is just going to be c, okay, regardless of what that number is, in either case. So if we say the limit of 5 as x goes to infinity, that's still 5. The limit of 5 as x goes to 0, that's still 5. If you think about this in terms, what you're really dealing with here is that you're saying that the function we're dealing with is y equal to 5, which is a horizontal line. And if you think about what it means for the limit of c, or y equal to c there, the idea is, what is the y value doing as the x value does? Fill in the blank, as it goes to a. So regardless of what it's doing, it's still going to c because it's horizontal, so the y value is always the same. So there's our first rule to keep in mind. Another rule is if we're just simply dealing with the limit as x that goes to some value, and I'm going to write this in a more generalized version of this go around. Let's just say it goes to a of some function f of x. That just simply means we're going to do f of a. Now, I've done another video where I dealt with rational functions, and the issue with the rational function was that if we plugged in the a into the function, we end up getting something that was undefined. So this is where I have to put in a caveat with this, okay? So the limit of f of x as x goes to a is f of a, but you have to pay attention, okay? You need to make sure you pay attention to except when f of a is undefined. Okay, and when f of a is undefined, then we're going to need to use other tools at our means in order to do this. Okay, and one of those things that I've talked about in some of my other videos was a graph, and something that we're going to look at in more detail as well is using a table to do the same thing. And we're actually going to look at that idea in a little bit more depth here, because I do think that is kind of a misunderstood law a lot of times when it comes to limits, is this idea of, well, if it's undefined, we get, and this is a Dr. Kuhn rule right here. Let's just say we have the limit of some function f of x as x goes to a, and we get undefined. Okay, that's what this caveat rule is talking about. That's what that is, right? Is undefined. What this means, this undefined is not your answer. What this means is do more math. Now, some of you are like, oh, I didn't want to do this math to begin with. Well, I'm sorry to hear that. Calculus is awesome. You're not seeing it correctly. When you see it correctly, it starts to get a lot cooler. And that's not an easy process. You do have to kind of invest yourself into that process a little bit for it to really start to sink in. But if it's worth the process, right? There's a children's book where the one creature says to another creature, waiting's not easy, and the other one says, well, it'll be worth it. This will be worth it, okay? If you keep working on it, it will be worth it. But let's just think of this another perspective as well, okay? Let's think about how else we can deal with this. So let's say we have the function 1 over x minus 5, okay? And we want the limit as x goes to 5, okay? Of 1 over x minus 5. Now, obviously, if we plug in 5 at this point, we get 1 over 5 minus 5, which is 1 over 0, which is undefined, which means do more math. Okay? That's what that means. I'll put a little arrow here. That's do more math. So we got to do more. Okay? This is one of my things I like to do. I want to put 5 in the middle. 5 is undefined. Don't know what it is. Right? But what I can start to do on either side of this is I can think about what are the values really, really close to 5. 5.1, 4.9. Now you're thinking, those are close values, but you put them at the end. Yes, because I want to get closer to 5. So what's closer to 5 from 5.1? 5.01, 5.001. From the other side, I could do, now be careful with this one, how you do this. It'd be 4.99, 4.999, right? And you can get perpetually closer to those. Now, if you have a graphing calculator, this becomes really simple to do. You just type in this into your function, and then you go pull up your table, and you set your table to ask, and in which case what it does is it actually waits for you to figure out those values and plug them in. In this case, what we're actually going to be talking, I can do most of these calculations in my head, but you can have the calculator just type in 5.1 into your table, and the calculator automatically tell you what it is. In this case, you'd have 5.1 minus 5, which is 1 over 0.1. 1 divided by 0.1 is 10. And then 5 minus 0.01 minus 5, and you divide that into 1. That is 1 over 0.01, which is 100, and then the next one is 1,000. And then from the other side, you actually end up with 4.9 minus 5, which is negative 0.1, which gives you negative 10. And then you end up with negative 100 and negative 1,000. And you keep going. So the biggest piece that you really should be paying attention to at this point is the fact that this number and this number are getting both really big in their own perspective ways, but they're going in different directions. This one is getting more, this one is positive and it's getting bigger. This one's getting negative. This one's negative and it's getting bigger, if you will. The absolute value of it's getting bigger. So they're going in different directions. So from one side, it's going to infinity, and from the other side, it's going to negative infinity. So this is one of those instances where we really have to look at this from two perspectives. As x goes to 5 from the left, okay, of 1 over x minus 5, that's equal to negative infinity from the left-hand side, right? And then the limit as x goes to 5 from the positive side of 1 over x minus 5, that's going to infinity. Now, on another video, I've actually talked about this as well from a different perspective, but the thing I kind of glossed over on that one that I want to spend more time talking about is these two have to match. Okay? They have to match. The limit from the right and the limit from the left have to match each other. If they do not match each other, then it means that the limit as x goes to 5 of 1 over x minus 5 does not exist. And that is an answer. So you're saying, so undefined was not an answer, but does not exist is an answer? Yes. Undefined means we don't know what the behavior is. That's actually the mathematical aspect of undefined, is we don't know. It's undefined. If you look in the root of the word, we define something. If it's undefined, it means we don't know what it is. So the whole concept right here is that we don't know what the limit is. So we do more math. Maybe there is a limit, maybe there's not a limit. So in this particular instance, there's not a limit. So we do more math, we find there's not a limit, and we have our answer. This is a different amount of information than this. Here we don't know what the behavior is. Now we know what the behavior is, now we can state the behavior. Okay? And there's the difference. So there's a couple of the big ones as far as laws of limit laws, if you will. There are some others that we need to talk about as well, but these are the basis that kind of get us going, and then we can kind of extrapolate from all that. All right, thank you for your time.